Okay guys, in this video we're going to take a look at the graphs of y equals sine theta and y equals cos theta. So you notice that the x-axis is labeled with the angle. On my sort of diagram here I've got it in degrees, but you need to be able to do it in both degrees and radians. So I'll just label a few of them in radians here. So 90 degrees we know is pi over 2 radians, 180 degrees is pi radians, 270 degrees is 3 pi over 2 radians. 360 degrees is 2 pi radians. Hopefully you can see we're going up in 90 degrees or pi over 2 radians. So the next one would be 2.5 or 5 pi over 2. Oops, sorry, 5 pi over 2 radians and so on. Okay, negative 90 degrees is just negative pi over 2, etc. Okay, so if we take a look at the sine curve, we know that when theta is equal to 0, the value of sine theta is also 0. So that means that this curve goes through the origin. Now, as theta gets bigger and approaches 90 degrees or pi over 2 radians, we can see that the value of sine theta approaches 1. Okay, and when theta is equal to 90 degrees, then sine of 90 is 1, okay? And as we go from 90 degrees to 180 degrees, we can see that the value of sine theta approaches 0, okay, and reaching 0 when theta is 180 degrees. Okay, similarly, when we go from 180 to 270 degrees, the value of sine is now negative, okay, reaching negative 1 when theta is 270 degrees, and we could complete our circle getting back down to 360 degrees where sine of theta is 0. And you can see that this graph will go on forever and ever and ever, sort of constantly repeating. If we look at the negative angles, so start back at 0, and now I've got a negative angle here, you can see that the sine of negative 90 is negative 1. And that makes sense because the negative 90 is the same angle as 270 degrees. Okay, so they've got the same value, negative 1. And so on. Sine of negative 180 is 0. Sine of negative 270 is 1. And so on. Okay, so there's a couple important things we need to note about the sine curve. So the first is that the graph of y equals sine theta is a periodic graph, which means it repeats, and it repeats every 360 degrees. So we say that the period is 360 degrees or 2 pi, okay? Also, we can see that the maximum value is 1, and the minimum is negative 1. So from that, we say that the graph has an amplitude of 1, okay? So these are your really important things here, the period and the amplitude. Okay, we also know that this graph goes through the origin, so it goes through the point 0, 0. Okay, similarly, we're going to look at the graph of y equals cos theta. You can see that it's got a similar shape, or the exact same shape as sine theta, except that when theta is equal to 0 degrees, you can see that cos of theta is equal to 1. So cos of 0 is 1. As the angle approaches 90, the cos of theta approaches 0. So cos of 90 is 0, and so on. So again, really similar to the sine curve, the period is 2 pi again, so it repeats every 360 degrees. The amplitude is 1. This time it goes through the point 0, 1, okay, so that's your y-intercept. And also, we can just see that the cosine curve is just the sine curve shifted or translated to the left 90 degrees. So if I drew the sine curve, I'll just draw a little bit of it. I get something like this. So the cosine curve has just been shifted 90 degrees to the left. Okay? Okay, so on your handout, you've been asked to plot the graphs of quite a few different cosine sine curves. So I'm just going to do a few with you so we can see what happens when we change the graph a little bit. So the first thing you're going to have to do is make sure that you're graphing things in radians. So if you go into the menu key and then number 9 is settings, you need to make sure that the graphing angle is in radians, and you might as well change this to radians as well while you're there. Okay, press OK. So let's start by doing cos of x. So over here we have the trig functions. We want cos of x, and we press enter. Okay, so we've got our cos graph there. I'm just going to change the window settings a little bit so that I can see the graph a little bit better. So if I go to menu, window zoom, and then the settings, the minimum and maximum of x are okay, but the y minimum, I know I'm only going to go between -1 and 1, so I'm just going to change this so that it's just a bit smaller. So say -3 and 3. Okay, so there's my cosine curve. Now let's draw the graph of y is equal to cos 2 of x. So cos of 2x, and I press enter, and I've got something like this. So what is happening to the graph? Well, you can see that it's been squished a little bit, okay? And what's happened here is we've changed the period of the graph. So the original graph was the blue one, and we can see that the graph has a period of 2 pi. Whereas if you look at this one here, you can see within one cosine curve, you've actually got 2 of the red curves. So the period has been cut in half. And so what happens here is that 2 changes the period of your graph. So I've just zoomed in a little bit differently here so you can maybe get a better picture of what I'm talking about. So the original one here is the cosine graph, and you can see it starts up here, and one period of the graph goes up to this point here, and that's a 0.2 pi, or about 6.28. So hopefully now you can see that the red graph, the period of it is half as big. So this point here, although we can't see it, that's just going to be pi radians, or 3.14. Okay, so the period has gone from being 2 pi in the blue curve to just pi in the red curve. Okay, now we're going to take a look at what happens when you've got something like, we'll start with y equals sine x, and now I'm going to do the graph of y equals 2 times sine x. Okay, and so now we can see that the period of the graph hasn't changed, but the amplitude has changed, and now the amplitude, instead of being 1, so the original curve was the blue one, y equals sine x, the amplitude is now 2. So that number outside of the function, 2 times sine x, is going to have an impact on our amplitude. So now we'll just take a look at how we would sketch a graph. So remembering from what we just did, that A tells us the amplitude of the sine curve, or the cosine curve, same thing in this case here, and N tells us about the period of the graph, and the period is always going to be 2 pi divided by whatever N is. So let's take a look at this example here to see how we would sketch this graph. So I've got y is equal to 2 sine 3 of x. So I know that my amplitude is going to be 2, so that I can just mark on this graph that the maximum value is going to be 2, and I'll just make this a bit bigger. The minimum value is going to be -2. Now, the period is going to be 2 pi divided by n, and in this case n is 3. So the period is going to be 2 pi over 3. Now I'm told that I want to draw the graph between 0 and 2 pi. Okay, so we have to, it's a bit more difficult because we have to think in radians here. But what we can do is start by drawing the sine curve. Okay, that's one period of the graph. So I know that that point there is going to be 2 pi over 3. So now I'm going to draw it again. And now that's another 2 pi over 3. So altogether I have 4 pi over 3. And if I draw it again, then this is going to be another 2 pi over 3, which is 6 pi over 3, or just 2 pi. So that's my whole interval there from 0 to 2 pi. So we're going to mark some important points on the graph. So we should mark all of the x-intercepts. So if that's 2 pi over 3, this intercept here is going to be half of that, or pi over 3. So this one's going to be, if that's pi over 3, 2 pi over 3, that's going to be 3 pi over 3, or just pi, 4 pi over 3, 5 pi over 3, and 6 pi. Okay, so there we've sketched our graph. So the important things to note are the amplitude and the period, and then we need to mark in our x-intercepts.